All right, today we're going to be covering over mid-segment theorem, and it says classwork because honestly, the notes for this one is really, really short. Um, it's a pretty okay, easy idea considering the stuff that we've been doing prior. So, mid-segment theorem states that the segment joining the midpoints of two sides of a triangle is parallel and half the length of the third side. So they have these things that are segments that are kind of splitting these into midpoints. So I got a midpoint here, a midpoint here, a midpoint here. Remember what a midpoint does? A midpoint splits it into two congruent pieces. So that is to say that that midpoint on the left-hand side is splitting it into two parts that are equal. The other midpoint on the other side is doing the exact same thing. So because this is a midpoint, then I know it's creating two congruent sides. So I'm going to color code that in a different color because this is a different side. And then finally, we have this other midpoint down here, and that also creates two congruent sides down here. So I have these segments that are being connected by midpoints, just like that. And it's creating these segments, right? So when I connect this midpoint with this midpoint, I get this segment. What the theorem is stating is that the segment joining the midpoints of the two sides of the triangle is number one, parallel. We don't use that too much, but we do use the fact that it's half the length of the third side. What does that mean? Well, what that means is you see how we have this big side right here in green? Notice that it's made up of two of these three tick mark pieces. Well, this piece is going to be parallel to the green side, and it's going to be half the size. So if there were two of these guys, half of two is going to be only one of those things. So I can state that this length must be the same length as one of those little pieces. I can say it also has a three tick mark, but instead of having two of those pieces, it's just going to be one of them. Now, just to kind of wrap my head around, let's say this was 10, right? This full length was 10. Then that means each one of these little pieces would be 5 and 5. And because that line above it is half the length of the full piece, half of 10 is 5. So then this piece would be only one of those 5s, where this piece would have two of those 5s. Okay? So basically, you're taking that big piece and you're cutting it in half, and that's how you get this other piece. Alternatively, if you knew that this was 5, right? Since this is half of the big piece, then you can take that 5 and say, oh, 5 times 2 equals 10. So you can go both ways. We tend to go more this way than the other way, okay? We usually start off with the small piece, double it up to get the larger piece. It makes the math a little bit easier sometimes. But guys, that doesn't only work over here. It also works for my yellow side. You see that yellow side? I have two of these yellow pieces. Well, then the mid segment on this side must be the exact same thing as one of these, right? Or it's got to be half of one of these. So I can go ahead and color this yellow and say this needs to match up with one of those pieces on the other side. And then finally, I can go ahead and do the exact same thing here. On the pink side, there's this big piece here. This is going to be half that size. So instead of having two of them, I'm only going to have one of those double tick marks. And I get to say that that length, whatever that big thing is, I need to cut it in half to get the little piece in here. So again, the relationship goes either you take this, whoops, that's the wrong color. You either take this big piece and cut it in half to get the small piece, or you can take this small piece and double it in order to get the large piece, okay? Um, Doing the second one, the one we just talked about, is a lot easier. In fact, that's exactly what's going to happen here. Notice that I have a midpoint. I have another midpoint. I know they're midpoints because the tick marks are the same on both sides. And I have this line connecting it here. So we're going to call that a mid-segment, okay? According to this theorem, this piece right here is going to be half of this. Or I can also say that I need two of these in order to make one of these. So we're going to take this piece, that's 7, and I'm going to double it up in order to get my x. The way we're going to write that is I'm going to take that small piece, 7, and I'm going to double it up in order to get the full length of x. 7 times 2, that's 14, and I get to say 14 is equal to x. And that makes sense because if I were to kind of split this up into two pieces, like this, then this piece would be 7, that piece would be 7, you get the 7 plus 7 is 14, okay? Remember that according to the theorem, we have a picture that kind of looks like that, all right? So again, we're just going to double up this piece, and it's going to equal the large one, all right? Okay, we have a different midsegment here. This time the midsegment is going sideways. So I see that this is the midpoint, this is the midpoint, and I have a midsegment connecting these. I know it's going to take two of these things to make one of these. And that one in particular is going to be that 3x minus 6. So again, I'm going to go ahead and say it's going to take two of these little ones. It's going to take two of those x plus 4s in order to make just one of these pieces, which is a 3x minus 6. I'm glad I wrote it with that parentheses because that's reminding me that I need to distribute. That's going to say 2x plus 8 is equal to 3x minus 6. I'm going to go ahead and subtract 2x on each side. 8 is equal to x minus 6. I add 6 to both sides, and I get that x is equal to 14. Okay, so hopefully that makes sense to you. Again, take two of the smaller pieces, it's going to equal to one of the big pieces. Take two of the smaller pieces, it equals one of the big piece. You can go backwards by taking the big piece and taking half of it, but the algebra on that makes it a little bit more funkier. So I'd always go the other way. All right, go ahead and take a minute, go ahead and jot down that challenge problem. And right now, what I want you to do is I want you to press pause on the video, and I want you to take a good 3-4 minutes and see where you can start with this. I know there's a lot of variables going around on that problem, and that's okay. But what you want to do is you're going to try to see, well, which one of those sides can I tackle first, and how is that going to help me solve the rest of those variables? So press pause on the video and take a good attempt at this before you move on. Okay, I'm going to assume that you already did that. And so we're going to go ahead and start trying to look at relationships and see which relationship is going to work. So for example, and I think the most students would start looking at this side and try to compare it to two of these sides, right? So how are you going to state that? Well, if I do that, the first thing I notice is that I have an x here, and then I got some y's going on there. So I have x's and y's. That's a lot of stuff going on for one equation, so I'm probably not going to start there. Same concept here. If I start looking at these sides, like this and like this, on this one I have a z, and on this one I have a y, so there's too much stuff going on there for me to try to set up one equation with it. However, if I start looking at this side, I see that that's 18, and I look at this side, I see that that's a z. I should be able to work with that one first. So let me go ahead and start highlighting these. I know it's going to take two of these z's to make one of these 18s. So I'm going to go ahead and write that 2z is equal to one of those 18s. That is to say 2z is equal to 18. You're going to divide by 2 on both sides, and you get z equals 9. So far I have one of them. I was able to figure out that z equal 9. So this one, check. Now that I know that this is 9, I get to go ahead and write that here. And I start looking around my problem, and I see, well, does that help me anywhere else? And I see that I have another 9 over here. This is going to be a 9 plus 1, which means now I know this side is 10. So instead of calling it z, let me just go ahead and call it 10. And since that's a 10, now I can go ahead and start setting up this relationship here. I know it takes two of these to make one of these large pieces. Now you have a 10 and just the y. You're going to be able to solve this equation. So 2 of these makes one of these. I'm going to go ahead and write 2 times 10 is equal to one of those 4y plus 4s. That means 20 is equal to 4y plus 4. Subtract 4 on each side, I get 16 is equal to 4y. Divide both sides by 4, I get y is equal to 4. Now, I know z and I know y. I should have highlighted those, and I didn't. Let me go ahead and do that right now. 2 of these 10s was equal to 1 of these 4y plus 4s. All right, and then the last thing we're gonna do is we're gonna go ahead and try to find the last piece, which means I must be matching up this side with this side. Let's see, what do I know? I know that y is 4, so let me go ahead and write this down here. This is gonna be 3 times 4 minus 5, 12 minus 5, which is 7. Now, be careful with this because in this case, we're going backwards, right? If this is 7, then that must mean you have a 7 and a 7, which means the full length is 14. But again, you don't want the full length. This big piece is equal to two of these pieces. So what I can write is that 2x is equal to 14. Divide both sides by 2, and I get x equals 7. That is probably the longer way of doing it. Um, The faster way of doing it would have been just saying, like, oh, I know that this piece is the same thing as one of those pieces, right? So since this is 7, this is 7. You didn't have to double it up. If you recognize that from the beginning, good on you. Go ahead and just jump in, and you don't have to write any equations. If this piece is 7, you know this piece is 7. But I think most students are probably going to say, oh no, I got to get this full length and get the 14, and I know two of those and do exactly the relationship we did. Regardless, we got the right answer, which is what's important. The other thing I do want to note is I just assumed that these were mid segments, and really, we shouldn't have done that. I was supposed to have marked these things from the beginning, that this side was this side was this side, and this side was this side here. But I forgot. I'm sorry. Next time I'll make sure I have that done. All right, that's all we have for today. As always, if you ever have any questions, please feel free to ask.